This is atom, and this is an atom. While they might sound the same, atom is made of atoms, but atoms are not made of atoms. Basically, this is an atom. It has a nucleus that is surrounded by electron shells. The nucleus is composed of protons and neutrons. Protons have a positive charge, neutrons don't have a charge. This makes the nucleus of an atom positively charged. Because an atom has a neutral charge at rest, every proton in an atom is accompanied by an electron. Electrons have one negative charge that balances out the proton's positive charge. To find out how many protons an element has, you can look on the periodic table. The periodic table increases in proton number from left to right and from top to bottom. For example, this is the New York State Chemistry Regents Reference Table. The proton number is listed in the bottom left corner. Oxygen has 8 protons, meaning it has 8 neutrons and 8 electrons. We can draw a very simple version of what this looks like. This is the 8 protons inside oxygen, and this is the matching 8 neutrons. In most models, this is condensed into a simple circle with the element number or the proton number written on it. For the electrons, it's a little more complicated. The first electron shell has a max capacity of 2 electrons, and it needs 2 electrons to be stable. Oxygen has 8 electrons, meaning we'll fill those first 2 and have 6 left over. The next shell holds 8. Oxygen has 6 electrons left, meaning that this shell is 3/4 full. There are technically 4 areas where electrons can be located. For drawing purposes, they are located here, 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 and here. Electrons disperse into pairs, meaning that these 2 electrons pair up and these 2 electrons pair up. Because there are still 2 spaces that need to be filled, these 2 electrons don't pair up and instead they go 1 to each. That means they still need a partner. These 2 spots can be filled by different atoms, including hydrogen, which has 1 electron. 2 hydrogens and an oxygen makes the molecule H2O, aka water. The bonds that form here and here are called covalent bonds. Covalent means that they share the electrons. You can confirm that this is a stable molecule because the first shell of the hydrogen has its 2 electrons and the oxygen has its 8 electrons. Now to talk about electronegativity. The nucleus of an atom pulls out the electron shell surrounding it. The closer the shell is to the nucleus, the stronger the pull. It's like tug-of-war. The closer you are to the other person, the easier it is to pull them over the line. Electronegativity is how badly the atom needs the electrons. Because oxygen only needs 2 more electrons to fill its shell, it pulls hard at the other atoms. That makes it a very electronegative atom with an electronegativity of 3.4. The most electronegative atom is right next to it on the periodic table, fluorine. Fluorine only needs 1 electron, meaning it pulls the hardest for it. Fluorine has an electronegativity of 4.0. Sometimes it can be called the Tyrannosaurus rex of electronegative atoms. As you go from left to right on a periodic table, the electronegativity increases as the protons increase. However, as you go from top to bottom, it generally decreases as there is a greater distance between the protons and the electrons it's trying to pull in, making it more difficult. Because the oxygen is so electronegative, it pulls really hard at the electrons from the other atoms. In H2O, for example, the hydrogen is weaker than the oxygen and therefore its electron is being pulled towards the oxygen. This creates a more positive charge on the hydrogen because it almost loses its electron. On the flip side, this creates a more negative charge on the oxygen because it almost gains 2 electrons from the hydrogens. This creates polar ends, like on a battery, and makes water a polar molecule. This concept of polarity and electronegativity really only apply to these atoms, which are known as nonmetals. Side note, this is a very simplified explanation of both of these concepts. There are exceptions, rule breakers, and so much more, so please don't take this as a set rule. This is just a good explanation for the following videos. The opposite of a polar molecule is a nonpolar molecule. As you can probably guess, a nonpolar molecule does not have the positive and negative ends that polar molecules have. For example, methane is a nonpolar gas. It has 1 carbon in the middle and is surrounded by 4 hydrogens. The carbon pulls the same amount at each hydrogen, meaning that there isn't really an end with more electrons or an end with less electrons. This pattern can be seen in biochemistry in the sense that molecules made of carbons and hydrogens are usually nonpolar, like oil. Oils, otherwise known as lipids or fats, are mainly just long chains of carbons and hydrogens and lack polarity. When you put nonpolar substances in a mixture with polar substances, they don't really mix well. Think of oil and water. When you pour oil on top of water, the oil stays on top and does not mix in. The phrase associated with this is like dissolves like. Polar dissolves polar, nonpolar dissolves nonpolar. The last thing for this video will be hydrogen bonds. Hydrogen is a very special atom. It is the smallest atom on the periodic table and it is responsible for several processes. When hydrogen is bonded to fluorine, oxygen, or nitrogen, it creates a very polar molecule. Think of this molecule of water. In nature, this molecule is usually not alone and is instead accompanied by other H2O molecules. In a cup, this negative oxygen end ends up pulling at this positive hydrogen end. This creates a hydrogen bond. The hydrogen doesn't actually bind to the oxygen, but because of how negative the oxygen end is, it might as well be. This strong connection between the two allows for things like surface tension, adhesion, and cohesion. If you've ever seen a video of a water strider, that is basically what allows the bug to stay afloat. Alright, that's all I have for this one. Thank you for watching, and I will see you in the next video. Peace out.